Hello everyone, welcome back to Discrete Mathematics and its applications with me Adila Krishnadi. We are now at the point where we want to discuss the solution to these exercises. Um, and we have two questions in this exercise. First one asks you to give a partition for given equivalence relation. Well, first check the relation is indeed equivalence first, and then the second you are given a collection of sets. Check whether these sets form a partition uh, so to set of pairs of integers, and if so, find the equivalence relation that yields the partition. So let's start with the first one. You want to first check whether R is an equivalence relation, and this should be pretty easy. Just check the reflexivity, symmetry, and transitivity. But just to denote that, remember here or note here that Lx is the length of x, so the number of characters or symbols or the number of bits in x, and then h2x is the first two bits, so the string form of the first two bits of x, with exception where we define h2x to be the empty string if the length of x is less than 2. So it's reflexive. Well, why is it reflexive? Clearly, well, you see, for x in S, you know that that L of x is L of x, and of course h2x is h2x. So therefore x must be R, right? Then for the symmetry, so if for x, y is S, if x comma y is in R, then we have that actually L of x is of course same as L of y, and h2x is the same as h2y, and this is of course implies that L of y is the same as L of x, and h2y is the same as h2x, and this means that y of x is zero. So it's symmetric. So how about transitivity? Here, note that for x, y, z bit strings, we know that if x comma y is in R and y comma z is in R, then you have L of x, so L of y, h2x equal to so this means that this L of x is equal to L of y, h2x is equal to h2y, and also L of y is equal to L to z, and then h2 of y is equal to h2 of z. So this implies that of course L of x is equal to L of z, and h2 of x is equal to h2 of z. Therefore x comma z must be in R as well. So it's transitive. Yeah. So you know that the and R is an equivalence relation. Now, what will be the partition? Well, because we look at set of bit strings, so we just start with a few examples. So the smallest bit string that we consider will be the empty string, and the equivalence class of the empty string would be, well, would contain the empty string itself, because this is the only one with length 0. What about strings of length 1? We have 2, and in fact they are of the same equivalence class. So because both 0 and 1 are of length 1, and h2 of 0 and h2 of 1 is the same, which is the empty string. Now how about string of length 2? Oh, then this is different. So you have this and this. 0, 1, it's on its own equivalence class. 1, 0 is also on its own equivalence class, and then of course and 1, 1 is in its own equivalence class. So you see why, because they are all have different value of h2. Now how about bit strings of length 3? Then this is an example of it, and this is in fact contains 0, 0, 0 and 0, 0, 1. Note that both of these strings are of length 3 and the first two bits are the same. Similarly, you have of course 0, 1, 0, which consists of 0, 1, 0, 0, 1, 1. Also 1, 0, which gives you 1, 0, 0 and 1, 0, 1, and then this 1, 1, 0, which consists of 1, 1, 0 and 1, 1, 1. So these are the equivalence class. Now how about strings of length 3? Well, you do the same thing, right? So you just take, for example, so a string of length 4, then this would contain 4 bit strings, 0, 0 and then 0, 0, 0, 0, then 0, 1, 0 and 0, 0, 1, 0 and 0, 1. Similarly up to like this one, which gives you 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0 and 1, 1, and so on, right? So length 5, length 6 and so on. So that's the answer of question 1. About question 2? Question 2, you are given 3 sets. First, show that these 3 sets is a partition of the set of pairs of integers, and if so, give the equivalence relation R that gives the partition. Well, so we show first that to show that these 3 are partitioned, so we must show first that each of these A1, A2 and A3 are not empty. So which is true because you know that A1 must contain some numbers, right? Because there exist 2 integers with 2 odd integers that exist 2 odd integers. For example, 1, 1 is in A1, and then of course 1, 2 is in A2. Then 2, is A. Now the intersection of A1 and A2 must obviously be empty. You look at the condition, you cannot satisfy both condition of A1 and A2 at the same time. Similarly, you cannot satisfy both condition of A2 and A3 at the same time, and you cannot satisfy condition of both condition of A1 and A3 at the same time. So they are all pairwise disjoint. Now finally, we show that the union of this is equal to Z times Z, And the answer is, well, first of all, note that A1 union A2 union A3 is a subset of this, right? Why? This is trivial, right? Why? Because, well, A1 and A2 and A3 are all sets of pairs of integers, so it has to be a subset. So their union has to be a subset of C times C. How about the other way around? Uh, the other way around, uh, uh, if x comma y is a pair of integers, then must be the case that either x comma y is in A1 or x comma y is in A2 or x comma y is in A3, because those three conditions on each of A1, A2 and A3 are the the only conditions that hold, are three disjoint conditions that could hold for all integers, all pairs of integers, right? It's all, there's no way for a pair of integer not to satisfy any of them. Now, how about the equivalence relation that yields the partition? Now, the idea is to look at each of the condition in the set and well write down the relation. So the main idea is that the relation has to be a set of pairs A, B, and C, D, yeah, such that this is an element of this. These pairs are elements of this pair of pairs here is element of Z times Z square, such that there is an I from 1 to 3 with what? With, of course, A comma B is in AI and C comma D is in AI. So in other words, A comma B and C comma D must belong to the same partition. So now, what will be the relation within A comma B and C comma D? This is what we want to describe, right? Well, the one above is already there, but the one above it is already gives us the relation, but we want to rewrite the condition so that we could easily check the condition. So note that A1 could be written this way, right? So this consists pairs x comma y such that, well, such that x is equivalent to y and they are all equivalent to 1 mod 2, right? Similarly, you could write A2 to be a set of pairs of xy such that x is equivalent to y plus 1 mod 2. Just, such that x is equivalent to plus 1. So they are all, so x and y must have different parity, so odd and even, or even and odd. And then of course A3 could be written x comma y is in this, such that x is y is equal to 0 on 2. Now notice that these three conditions are all disjoint, so there is no way for a pair x comma y to satisfy two of them simultaneously. So now we could combine this together. So will be if a comma b is in a1 and c comma d is in a1, then let's just rewrite it slightly. So you want to define R, which of course set of pairs a comma b, c comma d in this. Now when do these two pairs become related? They become related if they are both in a1 or they are both, we have two pairs here, right? They are both in a2 or they are both in a3. In the case of a1 and a3, we could actually combine the condition together. So essentially, if a is equivalent to b is equivalent to c is equivalent to d on 2. Now this captures both condition, because if a is congruent to b is congruent to c is congruent, and then they are all congruent to 1 modulo 2, then both pairs belong to a1. If a is congruent to b, congruent to c, congruent to d, and they are congruent to 0 modulo 2, then the pair of pairs a comma b and c comma d would belong to both pairs a comma b and c comma d would belong to a3. Now, how about a2? Well, so we have another condition. So, or of course we could simply write a is congruent to plus 1 modulo 2 and c congruent to d plus 1 modulo. Yeah, so that will be R, right? So this captures the whole thing, right? You could check this and you will be able to get given two pairs of integers, then you will be able to determine whether they are related by R or not. Now with that, we are at the end of the discussion or the session for equivalence relation, and let me end this and I'll see you in the next videos.